The other term that we look at, we're just going to talk about the term and look at a few things with it, but we will not be tested on it. So our learning targets for today. Students will be able to use median keyword and find the centroid, another keyword, of triangles. Students will be able to use altitudes, we already know what that is, and find the orthocenters of triangles. So orthocenters, finding the orthocenter can be pretty extensive. That is something that's not tested on. So we're going to look at an orthocenter. You want to jot a few things down about it, but we're not going to get heavy into those. All right, so 4 new words. One of them you already know, altitudes, but in a different context, kind of. Orthocenter, we don't have to stress about. So really 2 things to look at. First vocab word. A median of a triangle is the segment from the vertex to the midpoint of the opposite side. Okay, so the vertex to the midpoint of the opposite side. And there's going to be a better picture of this coming up, so you don't need to sketch this stuff. You don't need to write this part of it down. But a midpoint AC, maybe it's somewhere in here. The opposite side. The midpoint of AB would be like here. The opposite side would be C. Okay, so the midpoint of a line segment to the opposite side. The 3 medians of a triangle are congruent. Or concurrent now. Concurrent. I did that in the answer. The 3 medians of a triangle are concurrent. Point of concurrency is called the centroid. So we've looked at now, after reading this new term, we've looked at 3 different types of concurrency, or 3 different points of concurrency. The circumcenter, the incenter, and now the centroid, our 3rd type. So here's our centroid theorem. Here would be a good picture to sketch. 6.7. The centroid of a triangle is 2/3 fraction. 2/3 of the distance from each vertex, so from here to the midpoint of the opposite side. Right? So the centroid, so A, well, let's look at their example here. I'll give you about 30 seconds to get that one down. Then we'll work it out. That's what it sounds like to listen to head puzzles online. Right? So you watched all the head puzzles? Yeah. Right, Will? All the head puzzles we watched when we were virtual? I didn't know you existed until we came back to the person.
Yeah, I love virtual. It was great.
Virtual was great. So much less stress.
Right. Am I glad or aren't I glad? Yeah, I am. You know how when we were virtual, I'd come here and sit all day and just wait for somebody to email me because the lesson, like, I recorded it like 3 days beforehand just because there was some extra time. So it was already recorded, everything was already posted. I just had to hit publish and just wait for people to email. What? And I kind of
Did anyone email you?
What?
Did anyone email you?
Did anybody? Let's see. Who talked to me when we were virtual?
I talked to like
Ethan did.
I had a lot of trouble
questions.
submitting my one project.
I mean, I didn't have all of you when we were virtual, so. I probably heard from Chaz a few times, from Jack a few times, Alton once in a while. I don't know if I heard from Will. guys. Centroid. Okay.
Wait, what is this?
Let's look at this diagram. Get over it. We have a triangle, ABC. The medians, remember, the median of the triangle is a segment from a vertex, to the midpoint of the opposite side. So from B, the vertex, to the midpoint of AC, which we're saying is that. This would be our median. All the medians meet here at point P, and this point where all the medians meet is called our centroid. Now, the thing that they are talking about here at the bottom is if we look at A, AP, it is equal to 2/3, like the fraction, 2/3 of this whole thing, AP. Okay? Does that make sense? Fractions? I know we see fractions and we kind of lose our minds a little bit. But AP from one of our vertexes to the midpoint is 2/3 of from the midpoint to the centroid. Look at an example. Oh, you're making this sound really hard than that. In RST, point Q is the centroid of SW and RB. SQ equals 8, find Q, W, and S. QW. This is little segment right here. Check my setup, because we're going to set something up. It's not going to be too bad. Oops, I put it backwards. So we know that SQ, this whole thing, SQ, that 8, is 2/3 of SW. Okay? In our theorem, that's what they told us earlier. We know that SQ is 8. Can we solve for SW? Yeah, we can. Let me erase this. It's kind of a little bit messy. What would we do technically, like math-wise? What is it called? We multiply by what? The reciprocal. 8 times 3 is 24. Divided by 2 is 12. Okay? Sorry, it took me a second there to remember what we're looking at. But the big picture is, SQ, this longer segment, is 2/3 of the whole line there. So we can set up SQ is equal to 2/3 of SW. This would be considered the work. When I say show your work. And then we know that SQ equals 8. And that would get us our answer. Find the centroid. We may skip over finding the centroid. Well, do we want to skip over finding the centroid? You're going to have to do it on your homework. Do we even know how to find the centroid yet?
Yeah.
No.
You do? I don't think so.
Don't you just find the midpoint and then take it to the other side?
Yeah. We find the midpoint. Then we have to do some other stuff, and then we have to take 2/3 of the midpoint. Do we want to see an example? We probably should look at an example. Yes, Anastasia?
Did you guys
Did we find QW? Oh, no, we didn't. QW. So we know that the whole thing, thank you, the whole thing is 12, right? That section is 8, so QW is 4. Ooh, good job, thank you, sorry. I'm all over the place today. It was I didn't get enough sleep last night. And I haven't finished drinking my coffee yet. How about this? We'll hold off on finding the centroid because I will let you guys see if you can. But those that want to stick around, I will do one on the homework, the finding the centroid. So I'll do a homework problem for you. Let's get through our term so because we're already 11 minutes into the lesson. I feel like I've been talking a lot today. Using the altitude. So this term altitude we have already seen before. We just call it the height of our triangle. Okay? If we have in like 6th grade, they would give us a triangle and they would say the base is 12. And they would give you this dotted line and tell you maybe this was like 8, and then they would try to trick you and say that this side was maybe like 10. And remember, when you find the area of a triangle, it's what? What's the area of a triangle?
Base times height divided by 2.
Base times height over 2. And they would try to trick you, and they would want you to put that the height was 10. But the height is not 10, is it? No, the height is 8. Yeah, so they called it the height then. Now we just call it the altitude.
Why? That's so pointless. Why?
If the formula is base times height divided by 2, why would we call it?
We call it the altitude now.
No. It doesn't make perfect. I should just call it the height.
It's not very smart.
I mean, if you refer to it as the height, I will know what you're talking about. But we're changing the name of it. It's the altitude. Now, I don't think in 6th grade they ever did something like this, maybe, where the altitude or the height was on the outside of the triangle, so that might be something that we're adding. But, yeah, they probably didn't do that in 6th grade. So, know that the altitude could be on the outside of the triangle. Also, I don't know if it's actually called this, but you could think about it as like the true height of our triangle or the actual height. But moving forward, you'll see it as the altitude. Our formal definition, an altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or to the line that contains the opposite side. So I told you, you already know what that is. You already know what altitude is. No big deal. All right, orthocenter. I think it was our last term. Yep, and then just a couple kinds of general things. Our last new term. Like I said, you will not have to find the orthocenter. I might have accidentally put one on the homework, but we would cross that out. We would cross it out. Don't worry. You look ticked.
I looked at the picture and I was a little.
Yeah. No, the picture is a little bit interesting. So the orthocenter. Hang with me. Hang with me. We're almost there. The lines containing the altitudes. So if we take the altitude, right? Like, there's not just, in this case, there's not just one altitude. I guess that'd be another difference between the height of your triangle and the altitude. The altitude would be, there would be one here. Let's see, and then this would be another one. But we could have a couple of different altitudes, like you see more in this picture. So the lines containing the altitudes, where all of the altitudes intersect, is our orthocenter. So this would be considered, hang with me guys, this would be considered would this be our 4th point of concurrency? In center, circumcenter, just a second Ethan, I see your hand. In center, circumcenter. Too many centers? Well, the other one, I'm already forgetting our name, is the centroid, so not even the center. And now we have the orthocenter. Hey, you're in a lot of chat back there. And it's not Ben from Jack. Let's go, give him his pencil. I see a pencil right against the thing. Is that Jack's?
This is Chaz.
I think Chaz has nothing to do with
I
it.
have not been able to take notes in 5 minutes.
Okay. So this would be our orthocenter. Stay with me. You
guys have done a pretty good job.
You want to?
Why don't you just write down? Make sure you know what an altitude is, and it's just another sentence for orthocenter. The orthocenter, you think that one, Mia, was a long one? Orthocenter takes forever,
Yeah.
so it's not tested. But you need to know what the term is. But I'm not going to talk about it too much. Again, the altitude comes from one of our vertexes straight through the right angle, the opposite side. Just another side note, this is not something you need to write down because we kind of already know this from looking at the in-center yesterday. As shown below, the location of the orthocenter of the triangle depends on the type of triangle, right? We talked about this with, I think it was in-center yesterday. But if we have an acute triangle, the orthocenter would be on the inside. A right triangle, the orthocenter would be on the right triangle. In an obtuse triangle, the orthocenter would be on the outside. So just kind of a side note and relates it to the in-center from yesterday. Here are just a review of the terms that we've looked at. Right? We've looked at perpendicular bisectors. That was something that we knew from GOA. Now where all the perpendicular bisectors meet, we have the circumcenter. Okay, this might be a nice picture to save that just has all of these on the same page if it's something you want to refer back to, or your notes are always good. We knew the term angle bisector. Where all the angle bisectors meet, or that point of concurrency, we have called the in-center. Our new one today, the median. You can read me the definition of the median. Someone just notes. Anybody? Anybody? Yeah, Dave. Yeah. Yeah, so we have our vertex here. The midpoint of this line would be right there. That segment is the median. Nice job. The point of concurrency where all of the medians meet is our centroid, and then that last one we looked at, our altitude, where all of our altitudes meet. That point of concurrency is the orthocenter. You guys are lucky. We've got longer lectures in these first couple minutes.